I'm Yvette Montero, and today I'm going to talk about something invisible, unstoppable, and unnatural, which then is nanoplastics in drinking water. So, where the nanoplastics came from? Global plastic production has been exploded in recent decades, so the problem is that the plastic doesn't disappear, so it just breaks into very smaller pieces. So first we get the microplastics, then just keep splitting until they become the nanoplastics, which are smaller than 1 micrometer. Just to give you an idea, a human hair is about 70 micrometers wide, so a nanoplastic is 70 times smaller than that. So scientists, they're found into oceans, rivers, wastewater, and yes, even treated drinking water. What has the WHO found? The World Health Organization found that microplastics in tap and bottled water worldwide. But nanoplastics are different because they are so small and they have a larger surface area compared to their volume. That means they are more reactive. So they can interact with organic matter, bacteria, and possibly with human cells. However, the WHO says that there is not enough evidence yet to know the long-term health effects. So the scientists are in the middle of a scientific question mark. An analogy, it can be like crushed ice melts faster than a cube. So more surface, more action. The measurement problem. Here is a big challenge. There is no standardizing way to reliably spot and measure nanoplastics in water. So because of this, the US Environmental Protection Agency, the PIA, says that methods are still being developed. So why it is so hard? Because nanoplastics look very similar to naturally occurring tiny particles. Telling them apart from everything else in water is not easy. This uncertainty makes it harder to know how much we are actually exposed to. So it's like trying to count invisibly those particles in a wine room. Can water treatment remove them? So what about the water treatment? All methods, including coagulation, flocculation, sedimentation, and sand filtration. This removes some larger microplastics. But nanoplastics are a different story. Their small size lets them split through regular filters. Unless these particles clump together, basic filtration does not catch much. But advanced treatments like specialized membrane may need to become standard. Imagine trying to catch smoke with a mosquito net. That's how useless regular filters are against nanoplastics. So, how might nanoplastics affect the human cells? Now, the most important questions. How could they affect the human cells? Their size means that they could potentially cross cellular barriers, but studies with other kinds of nanoplastics suggest that small particles can stress cells out, so they might mess with the mitochondria, the power plants of your cells. So they could prompt inflammation and may change the gene activity. We don't know all the details yet, but researchers are digging into this. And that brings us to the next part, how genomics is helping to find answers. So we know nanoplastics exist, but we can filter them easily, and they may affect our cells. But how do we know to study these hidden effects? So we will explain how genomics and transcriptomics are giving us new clues. So, what can genomics and transcriptomics reveal? Using genomic and transcriptomic tools can reveal subtle biological shifts that are not visible by just watching the whole organism. Methods include RNA sequencing, quantitative PCR, and gene expression profiling. So the researchers can check if ongoing exposure to small amounts of nanoplastics affects detoxification pathways, oxidative stress pathways, and other inflammation pathways. So the combination environmental toxicology with molecular biology gives us a sharper picture. The scary part, effects might not show up the right way or could stay hidden for years. So genes are like a receipt book. transcriptomics tells us you what receive the cell is actually cooking it. What do the WHO and the EPA say about health risks? Both the WHO and the EPA state that current data do not point to widespread or severe health problems as today's estimated exposure levels. But there's the catch. A lack of solid proof does not automatically mean it's safe. So the difficulty shows how tricky measurements and methods still are. This entire field is pretty new. But as our detection tool gets better, most accurate reading will sharpen risk calls. So thinking of smoking in the 50s, it took decades before we had clear evidence. So why is this an emergency environmental concern? This is because testing is tough, so the science is still catching up and the toxicity picture is not fully clear. So official agencies are not calling it a public health crisis yet, but the way nanoplastics behave, their ability to cross barriers, carry toxins, and hide from the detections mean that the story is not finished. So this is exactly what an emerging concern looks like. So we don't have all the answers, but we have enough questions to worry. What is needed for the future? There is no real need to keep researching. We need better detection methods, smarter water treatments, and genome-level analysis should be used. Imagine the water treatment plants that not only filter but also test for nanoplastics contamination in real time. Or imagine a future where your tap water comes with a genomic safety report. That is not science fiction. It is the direction of the scientists that are working towards it. Key takeaways for teenagers. Let me leave you with the key takeaways, especially for students like us. So we all know that nanoplastics are ultra-small plastics particles in drinking water. They come from larger plastics breaking down over time, but we don't know yet if they cause long-term health problems, but measuring them is a very difficult process because they look like natural particles. So regular water treatment plants do not filter them out effectively, and scientists are using genomics to study possibly cell damage. Do not panic, but stay informed. The invisible things are often the ones that matter most. So thank you very much for watching the entire video. This was our PIA presentations of nanoplastics in drinking water. We hope you now see your glass of water with different eyes. Stay curious, stay scientific, and see you next time.